And welcome back as we continue our cosmic journey. Previously we had talked about keeping time, but now let's look at time on a grander scale by looking at the calendar. So what is the challenge of a calendar? Well, let's start by asking a simple question. What day is it? This is a very common question that you can ask anybody. So how would you solve this if you don't know what day is it? If we didn't have any kind of modern concept of time, how could we solve this dilemma? Well, the calendar is a very common and useful tool to work with our concept of time that we previously established. Now, there are two traditional functions of any calendar. First, a calendar must keep track of time over the course of long spans. We typically look at this, for example, years. And this allows people to anticipate the cycle of seasons and to honor special religious or personal anniversaries. Second, a calendar has to be useful to many people. It can't just be something that's useful to me. It has to be something that's useful to everyone. And a calendar must use natural time intervals that everyone can agree on. If you have your own custom time intervals, it's not going to help someone who doesn't understand that system. So the natural units on our calendar are typically days, months, and year, unless you're looking at some kind of specialized calendar. So what are the difficulties that you might have in using a calendar? And take this for a moment without thinking about the calendar that we use day to day. Let's just pretend the calendar didn't exist. Well, difficulties over time have resulted from the fact that these three periods, day, month, and year, do not divide evenly into any of the others. For example, when we think about things like mathematically, having things, for example, in factors of 10 is really nice, or you can have factors of 2 or 3 or 4. But, a day is, comprised of 24 hours. A week is comprised of 7 days. You have a month, which can vary anywhere from 28 to 31 days. So we have these very odd things. And if we think about this all comes back from the rotational period of Earth being pretty standardized, because it's by definition one solar day. Now, the period required by the moon to complete its cycle of phases, which we refer to as a month, is 29.5306 days. And that's not a quite as beautiful or even number here. If we look at the basic period of revolution of the Earth, which we call a tropical year, this is 365.2422 days. Again, you notice that while the solar day is really nice to look at, the month, by the definition of a moon's month, is not quite as even, and our period of revolution for the Earth, it's close to what we usually think of for a year, which is 365 days, but you can see it's not quite. Now, the ratios of these numbers, because they're all so different, is actually not that convenient for calculations. And this was the historic challenge of the calendar, dealt with in various ways by different cultures. So let's start out by looking at some very early calendars. Even the earliest cultures that we can think about, going all the way back to the Bronze Age, were concerned with the keeping of time and the calendar. Having a calendar was a very consistent way of planning for different events and rituals and stuff like that. Some of the most interesting examples were monuments left in the Bronze Age in northwestern Europe, especially in the British Isles. One of the best preserved monuments is Stonehenge in southwest England. And you may not think of Stonehenge necessarily as a calendar, but some of the stones are actually aligned with the direction of the sun and moon during their risings and settings at critical times of the year. And so, people have been able to put together that this was probably some type of calendar that was used long, long ago. And it's generally believed that because of you have this rising and settings that are kind of lining up, it was connected with the keeping of some kind of calendar. Now, we don't have the full know-how of what that calendar looked like, but this is just an example of one of those early calendars. There are other early calendars that are also older and stuff like that, but this, again, is just one example. Now, another one you might have heard about is the Mayan calendar. The Maya in Central America were also concerned with the keeping in time. So this doesn't necessarily mean we're just restricting ourselves to Europe. Even over in the Americas, before European colonization, we were trying to keep track of time. Now, the Mayan calendar was just as sophisticated and perhaps more complex than the contemporary calendars that would be later developed in Europe. Now, an interesting thing is, though, the Maya did not attempt to correlate their calendar accurately with the length of the year or necessarily with a lunar month. Rather, their calendar was a system for keeping track of the passage of days and for counting time far into either the past or to the future. Among other purposes, it was used for predicting astronomical events, such as the position of Venus in the sky. And so for them, the calendar had other purposes rather than simply just keeping track of what day it is. And of course, if we want to look at more of our modern calendar, we need to take a look at the birth of the Western calendar as we kind of know it. Our Western calendar derives from several ancient calendars that actually led eventually to the Julian calendar, proposed by Julius Caesar, which approximated the year at 365.25 days, which is actually pretty close to the actual value of 365.2442. Now, the Romans achieved this approximation by declaring years are going to have 365 days each. And they said, you know what, every fourth year, we're going to have a leap year, which was to have one extra day, 366 days, which if you think about it is not very far off from what we know about our modern calendars. Now, the Romans at this time, because up to this, a lot of people were relying on the moon for many of these things, but they dropped the impossible task of trying to base their calendar on the moon, because as you noticed, it was like 29 with a bunch of decimals on it, and they're like, that's too difficult. So, and trying to rely on the sun was also a difficult task. Now, we do have vestiges of older lunar systems baked into the Julian calendar, as you can see in the fact that our months have an average length of about 30 days. And because remember, the lunar month is approximately about 29 days. Well, the Julian calendar is not perfect, but we actually base our calendar not on the Julian calendar, but on the Gregorian calendar. Now, although the Julian calendar represented a great advance in standardizing calendars, its average year still differed from the true year by about 11 minutes. Now, you may not think 11 minutes, that's not too much, but by 1852, from when that calendar was first made, that 11 minutes per year had added up to the point where the first day of spring was occurring on March 11th instead of on March 21st. Pope Gregory XIII felt it was necessary to institute further calendar reform before, all of a sudden, like, Easter is going to be around when we have Christmas. So the Gregorian calendar reform consisted of 2 steps. First, 10 days had to be dropped out of the calendar, bringing the vernal equinox back to March 21st. That's when the equinox was supposed to be, and we were out of sync with it, so he's like, we just need to drop some days out just to bring it back in sync. The second thing was the leap year solution, because if you remember, the Julian calendar proposed every 4 years we're going to add a day. Well, the second feature of the new Gregorian calendar was a change in the rule for leap year, making the average length of the year more approximately close to that of a tropical year. Gregory decreed that 3 of every 4 century years would be common years henceforth. Now that might sound a little jargony, so let's break that down. So the rule was only century years divisible by 400 would be leap years. So when we talk about century years, that means things like 1700, 1300, and 1900. These are all divisible by 4. However, they are not divisible by 400, which means if these are indeed the case, they don't need to be leap years in the Gregorian calendar. On the other hand, years like 1600 and 2000, which are both divisible by 400, are leap years. In fact, the year 2000 wasn't that long ago, and the year 2000 was a leap year. When you come up on the year 2100, that year, even though it's divisible by 4, which typically is when we have leap years, because it is not divisible by 400, the year 2100 will not be a leap year. And now the average length of this Gregorian calendar, 365.2425 mean solar days, is correct to about 1 day in every 3,300 years, which means after 3,300 years, we're probably going to have to make another correction to make sure that we don't fall out of sync.